Cool. Welcome, everybody. We're going to get started right on time. So hopefully you're here to hear about how Twilio scaled its data-driven culture. If you're not, now is your moment to leave. We won't judge you. It's OK. My name is Daniel Mintz. I'm the Chief Data Evangelist for Looker. I'm going to do a quick introduction, and then I'm going to hand it over to Dara and Rahul, who you really are here to hear from. And they're going to tell you all about what they've done in deep detail that I know AWS reInvent folks love. Oh, that's me. Let's go past that. How many people here have been doing like data stuff for more than 3 years? More than 5 years? More than 10 years? All right, I won't embarrass people by asking more than 10 years because that can get rough. But for those of you who haven't been doing this for a really long time, one thing that you may not realize is that the world that you live in of like crazy fast, crazy cheap cloud databases is not a world that has existed for a very long time. It's a pretty new world. Until pretty recently, databases were very slow. They were very expensive. They were very heavy. They had to like come in on an 18-wheeler into your data center. And really everything that you decided to do with data in your company was mostly driven by your desire to not spend another $1 million to buy another server to put in your data center. That is not the world we live in anymore, right? There's been just an amazing proliferation of incredibly fast databases, everything starting from the sort of Hadoop ecosystem 10 plus years ago through Redshift, which came out in 2012, now with Athena and Aurora and, just like everything. And, lots of big players in the space are building these incredible databases. And that's a huge change. And it really changes the way that data can be used in the enterprise because it means that all these constraints that used to exist have kind of fallen away. Now, that's great. It's really neat and gives us lots of new opportunities. But there is a problem. Which is that while the database technology has changed tremendously, for the most part, the analytic tools that we're using and sitting on top of those databases mostly haven't changed. And much as saving your kind of worn out, kind of old tires and putting them on your new Tesla to save a little money, you're not probably going to get quite as much value out of your investment as you might otherwise if you don't upgrade your whole stack, right? If you're using an old analytic tool on these incredibly powerful new databases, those tools were kind of built in a world of slow, expensive databases and made a bunch of really smart compromises that maybe aren't so smart anymore because of those changes. So, I work for Looker, but before I worked for Looker, I was a customer of Looker's for 3.5 years when I ran data and analytics at Upworthy. And Looker is a tool that was built in this new world, brought to public in 2013, and so really is native to this world and is constantly thinking about and is architected for this world and thinking about how do we get as much value as we can out of these incredibly powerful, cheap cloud databases. So just to give you a sense of sort of what that looks like and how maybe that differs from what kinds of analytic tools you might be used to using, I'm going to give you a quick architecture of sort of how most companies' data looks today. So, most companies who we work with have a ton of different tools that are feeding them data. It's not one tool. It's not a POS system and nothing else. It's not, just a transactional database. They have a bunch of SaaS apps. They have their transactional database. Maybe they have an ERP. Web analytics, like there's just a ton of tools. And it used to be that process of pulling all that data out of those systems, transforming it, and loading it into your warehouse or your database was really hard. And that was because the databases were slow, and so you had to sort of reshape it and get it in the right format before you could put in those databases. It's not true anymore. The databases are fast, and so we can kind of just dump stuff in them and then handle that with the databases. And so that's what we encourage folks to do. And so the way that Looker works is you put your data in any SQL database, so that might be a transactional RDBMS, like MySQL, Postgres, Aurora. It might be something like Amazon Athena, where you're not actually even putting it in a database anymore. You're just putting it in S3 and deploying Athena on top of that. It might be Redshift Spectrum, where you're getting the best of both worlds, enterprise-grade warehouse and S3. Or it might be EMR using the Hadoop ecosystem. And once you've done that, once you've put that data in one place, what Looker can do is Looker then sits on top and accesses that data. But it does so in a way that makes sure that everybody who's accessing the data, whether the most technical, sophisticated DBA or the least technical business user, is always getting the same meaning from the data. When they ask, what is the lifetime customer value, they're going to get the same answer because Looker is in between them and the data. And your analysts have gone in and said, here is our definition company-wide for lifetime customer value. And if anybody asks for that, we're going to make sure they get the same answer. So Looker has this agile modeling layer, which sits on top. It also handles things like version control, which is a great thing that developers love, but for some reason, analytics have mostly not benefited from. But Looker gives you that, so you can version control your models. Connections to these databases, user management, security, all of that. And once you've got Looker there, that's this big, broad platform, what you can then do is access the data through any of a whole bunch of options. So most people use our web interface, using self-service exploration and our D3 visualizations. You can export that data to other tools if you need. You can schedule delivery because Looker's a platform, it's a server, it runs in the cloud. And so if you say, hey, rather than having to go get this, I just want it in my inbox every Monday morning, great, no problem. You can set that up. But you can also deliver things via webhook or FTP or push it to S3, so you can access that data wherever and however you need with Looker pushing it to you. You can also embed Looker in Salesforce or via iframe or JavaScript. And Looker, because it's modern software built in 2012, 2013 through now, has a full set of RESTful APIs. So you can, anything that you can do manually through the web interface, you could also do programmatically through an API. And in terms of how Looker works with AWS, we have more than 600 joint customers. More than 500 of them are using Redshift. Redshift is an amazing tool. I started using it right when it came out and using Looker right on top of it, and they are two great tastes that taste great together. We support a whole host of other Amazon products like the RDS and EMR, and where we have deep integrations and partnerships with Amazon. Lots of customers are getting a ton of value from Looker on their AWS products. If you already are using AWS databases or data engines, I strongly advise you to give it a look. I think you'll get even more value from the investment that you're making. And just to highlight two of those cases, so one is Casper, the mattress company, and they're using Looker on Redshift to do everything from supply chain management to understand, where are the mattresses in the supply chain? Are they arriving as scheduled? Are people getting them, under their SLAs? And then also all of the e-commerce analytics that you would expect a web-native company like Casper to do. So marketing analytics, web analytics. Another is Rovio, the maker of Angry Birds. They're allowing analysts and game developers to collaborate in a way that they hadn't been able to before, where developers can build custom metrics for their game while still leveraging the sort of core game metrics, MAUs, DAUs, that every game at their game studio needs to have. And they're allowing business users to self-serve rather than having to wait in line for an analyst to have time to write a SQL query to give them the data. That's just not an efficient way to leverage these databases. So in terms of Twilio, and I'm very excited for you guys to hear from them because they're brilliant and doing amazing stuff. They have been using Looker on Amazon for 3+ years, and in that time have grown tremendously in how many people are actually using it. And that's a real challenge. It's a new thing for hundreds of people, thousands of people across an organization to have real deep access to data. Not just dashboards and reports, but the ability to ask ad hoc questions, to find the answers, and to know that they're getting trustworthy answers. So they're running hundreds of thousands of queries each month to drive all across their business. So without further ado, I'm going to give you Terra Patel and Rahul Chandel, who are going to talk all about how Twilio is using Looker and Amazon.
Thank you, Daniel. So my name is Tara, and I'm leading the business intelligence division, which consists of the data engineering and analytics functions at Twilio. And I have Rahul with me, who is the tech lead for our data engineering group. So in today's session, we are going to talk about how we scaled our analytics platform and services to fuel the data-driven culture at Twilio. So I'll start with the introduction of Twilio, and we'll talk about who we are, what we do. Then I'll talk about the analytics at Twilio. So we'll talk about what the culture looks like, what are the processes that we use for analytics. After that, I'll hand it over to Rahul to talk about the evolution of our analytics architecture. And in the second half, I'll talk about how we use Looker at Twilio. And then I'll give you some tips and tricks to handle the performance at scale, specifically for two of the main systems that we use for analytics. And then I will conclude the talk by giving some business insights that we are able to provide using our platform. All right, so for those of you who are not familiar with Twilio, we provide cloud communications platform. So there are 4 parts of the Twilio platform. The first is the super network. We handle the interconnectivity with all the carriers, and this is how you get instant access to phone numbers, short codes, voice, and wireless connectivity across the world. The second is the programmable communications cloud, which consists of the communications APIs like SMS, voice, video, chat, etc. It also includes intelligent services like scaling your application globally or extracting intelligence from text and calls to gather performance insights. Third is the engagement cloud, which consists of the higher level software APIs that lets you build multi-channel communications between your systems, departments, and customers. And some of the examples in this cloud are Notify or Task Router. And finally, there is a runtime developer experience program which saves your team time and effort to build and prototype your Twilio-powered application. One such example is Functions, where you can build and deploy your application without worrying about servers. So now we know a little bit about Twilio. Let me give you some stats. So we have around 1.6 million developers on our platform who uses more than 50 APIs across all our services. We believe in continuous delivery to our customers and release new feature every 3.5 days. Today, Twilio.org supports more than 1,000 nonprofit organizations. And in last 1 year, we had around 28 billion customer interactions on our platform. So let's talk about analytics at Twilio. So analytics at Twilio falls into 2 main buckets, data warehousing and data exploration. The focus of data warehousing is to create the single source of truth for data. So it allows us to create consistent and correct use of data across Twilio. When it comes to KPIs, the cross-functional alignment is required across various business units and stakeholders. So at Twilio, it is supported by the Data Governance Initiative. So they help us standardize the definitions and create governed key metrics. One important aspect of data warehousing is the integration of various data points so that we can drive deeper insights. On the other hand, data exploration is all about finding the unknown. It allows users to explore who, what, when, and why about our customers and products. Profiling and discovery helps in establishing the correlations across disparate data sources and allows to answer any open-ended questions. It also allows users to create trends and behavioral patterns using historical data. As I mentioned earlier, we release new feature every 3.5 days. So rapid dataset prototyping is key for us to quickly build and measure our hypothesis. Self-service is a key aspect of our analytics culture. We truly believe in empowering our users to ask and answer their questions with data. At the same time, we enable them to share their insights with their team, department, or even with an organization using amazing tools like Looker. So next, let's talk about how do we prepare the data that enables Twilions make data-driven decisions. So at a very high level, there are 5 main steps involved in any analytics process. So the first step for us is to gather the data. At Twilio, we have many internal and third-party data sources from where we extract the data. A lot of this internal data comes in as events, and it arrives in real time. On the other hand, a lot of the third-party data arrives in few hourly or daily batches. All of this data is disparate in nature, and some of them are also high in volume. So once we gather the data, the next step is to integrate and transform. Since we are using so many different data sources, it is important for us to integrate the data from one system to the other to make it usable and also drive deeper insights. Transformations are also required to generate aggregations or derive calculated values as per the business need. So once the data is transformed, the next step is to make it available in the queryable systems. Now at Twilio, we host data in 2 different environments. One is our data lake environment, which supports the data exploration type activities. And second is our analytical databases, which supports the data warehousing type initiatives. Once the data is loaded, the appropriate access controls are applied so that users can self-serve their data needs. And the final step in the process is to analyze and explore. So at Twilio, Looker is a one-stop shop for both of these activities. So users can build their models or run one-time SQL queries to perform their exploration activities, or they can use the pre-built reports and dashboards to drive insights. So next, I would like to invite Rahul to talk about the evolution of our analytics architecture.
Thank you, Dhara. As we all know, Rome wasn't built in a day. Same story goes for us. We have also evolved our architecture over a period of time and have gone through several phases. I'll primarily focus on 3 main phases of our architecture and walk you through the details of how we went from phase 1 to phase 3. So, first component of our architecture is the extraction of data from internal and external data sources. At Twilio, most of our operational data is stored in MySQL databases. In addition, there are some third-party data sources that we use like Gainsight, Eloqua, and Salesforce. We have built processes to extract data from these systems and load them into our data lake environment, which is S3. Once the data is available in S3, it is then loaded into Redshift. Most of these are in-house programs that use source APIs. Let's talk about Salesforce, as it's one of the most critical source and consumer systems of data. In addition to making Salesforce data available in Redshift, there was also a requirement from business to push our customer usage and revenue related data into Salesforce. So we had to establish a 2-way integration between these 2 systems. We use bulk APIs to pull and push data between these 2 systems. Each API request returned a JSON formatted data for which we identified a predefined data type which was mapped to a schema and then loaded to a table in Redshift. As the volume was high, we created files in S3 and then used copy commands to load these data sets into Redshift. While we were designing our systems, we had only 2 goals in mind. First, that we must be able to incrementally load these data sets into Redshift so we can do smaller updates. And then second, that we must be able to modify these as and when needed. And finally, Looker is connected to Redshift where queries from reports and dashboards are executed. As this was the first iteration of our architecture, we ran into some challenges and at the same time had new business demands. So let me talk about some of the challenges first. As we were extracting everything from our MySQL databases, there was heavy load on our transactional systems. We were using shared environment for reporting and transformations, which was Redshift. As customer interactions on our platform grew, we ran into issues handling massive data sets. And at the same time, we were not able to handle disparate data formats and were only working with CSV and JSON file formats. Scalability here was clearly an issue as we were doing everything in one single platform. While we were dealing with our challenges, there were new demands from business. As we were loading anything and everything in Redshift, there was no clear single source of truth, as same metrics could be derived from multiple datasets. Business intelligence was a problem as we did not have governed datasets and standardized reports and dashboards which could be used by different business units. SOX compliance came in as a requirement as we were dealing with financial datasets. There was also a demand to add more and more third-party data sources in our system. So with all these, we came up with our phase 2 architecture. To solve the problem of heavy load on our transactional system, we decided to introduce Kafka data pipeline in our architecture. For those of you who are not familiar with Kafka, it's a distributed streaming platform that allows you to publish subscribe streams of records. In addition, it allows you to store and process them as they occur. We worked with our engineering teams to capture these data as events, and then instead of extracting them from our MySQL databases, we were directly getting them from Kafka. Once the data is available in Kafka, it is then loaded into S3, and then it goes to a Redshift environment. As of now, we have more than 60 to 70% of our events coming from Kafka. In addition to aggregations, we were writing complex transformation logics in Redshift which would trigger an expensive query and would compete for cluster resources against regular day-to-day queries. And then we realized that we needed a scalable environment which could do our transformations in a much better manner. And so for this reason, we chose Apache Spark. It's an open source cluster computing framework that can process huge amount of data sets. So once the data is available in Spark, it's then loaded into Redshift. As of now, we have more than 80% of our transformations running in Spark. It also provided us with pre-built libraries that we use to connect to disparate data formats, and that resolved our problem of handling only CSV and JSONs. To meet the business demand of SOX compliance and single source of truth, we decided to segregate our Redshift clusters into two, one with raw and one with governed data sets, which could be used for data exploration and business intelligence practices. One major enhancement that we did to our architecture was the evolution of peer-to-peer third-party integration process into a configurable service that allowed us to onboard any new third-party integration quickly, as we no longer had to worry about monitoring and failure management and some other common functionalities that were provided by this service. It's an in-house service written in Python. It's an abstraction on top of the APIs. Well, this worked for some time, but as the demands from business grew, we again started running into some challenges. So let me talk about those challenges first. As our platform evolved, we started creating different services for specific objectives, which also involved running jobs inside these services. Monitoring these jobs running across different services and handling dependencies between them was becoming a problem. We were using cron schedules and were heavily relying on time-based dependencies. So it meant if a job took longer than expected running on one service, then it meant other jobs running on different services were executed without enough information. So we had to identify the bottleneck and rerun impacted jobs, which caused delays in meeting our SLAs. There were also some new demands from business, like they were asking for real-time operational insights, and since we were running our Spark loads in daily and hourly batch fashion, we were not able to provide these insights. Businesses at the same time started moving from reactive to proactive analysis, and we had to respond to events as they occurred. There were also requirements to support data exploration initiatives for data science. So as the demand for real-time and historical data increased, we realized the need for a scalable approach to load these data sets into Redshift. So with all these, we came up with our phase 3 architecture. First component of our architecture remains same here, where we use Kafka to stream all our Twilio internal data sets as events, and then extract them into our Amazon S3 data lake. One new component that we added here was a layer of Spark and Redshift for data science activities. We also created a new loader service, which was configurable in a way that it could load any S3 datasets to any of these Redshift environments. It's an in-house service written in Python. It continuously looks for new datasets in S3. And you can also configure the service such as like table definitions, or refresh cycles, different file formats, which ultimately loads S3 datasets into appropriate Redshift environments. Our third-party loader service was also enhanced with new functionalities, and it remains a critical component of our architecture. Next major enhancement that we did to our architecture was the introduction of Spark streaming. Spark's unified programming model and a single programming model for Batch and Spark led us to choose Spark streaming. It's an extension of the core Spark API that lets us process huge volume of data sets. It allowed us to process events from Kafka in real time and then load them into our S3 environment. We now load medium-sized data sets into Redshift instead of huge ones that take hours to load. The reason for this is that when we wanted to stream data into Redshift in real time, we wanted to load them incrementally. To solve our problem of different jobs running across multiple services, we decided to introduce a workflow management platform. We chose Apache Airflow, where you can define your workflow definitions programmatically. Since we have multiple services running in our platform, we chose a distributed architecture where each service was augmented with an Airflow worker. And we keep our different services with workflow definitions synced using Git and Chef. We use Celery with Redis Broker for queue management and execute our task in distributed fashion. We also use Postgres for execution metadata and workflow definitions. Airflow also provides us with a web UI, which is very helpful for visualizing pipelines in production, and at the same time is helpful for monitoring and failure management. In the end, I would like to say that we are still evolving our architecture as per our business demands. With this, I would like to hand it back to Dhara, where she'll tell us more about Looker and some interesting business insights that we are providing using this platform.
Thank you, Rahul. All right, so let's talk about how we use Looker at Twilio. We have more than 700 active users on our Looker platform, which is pretty much 80% of the company. So we quickly realized that in order for us to support this scale, we have to distribute the ownership of Looker outside of our core team of analysts. So what it means is that we have empowered our business units and product teams to build their own models, reports, and dashboards, and also contribute back to the Twilio Looker community. As power comes with responsibility, our core team of analysts do provide guidance and ensures the stable production environment. So there are two types of users we support on our Looker, the developers and non-developers. So developers are the people who build Looker models using LookML. So LookML is the data modeling language for Looker. And non-developers are primarily reports and dashboard users. We have connected our Looker to GitHub, which allows our core team to review all the model changes before they are released to production. It also allows us to do the version control on all of our models. So today we have over 50 LookML developers in Twilio who makes more than 100 contributions per week. So with so many users in Looker, we surely cannot get away without proper access control. So we have connected our Looker to Active Directory so that we can leverage the role-based user groups, because surely people in finance needs different access privileges than people in messaging or voice teams. We have also designed our permission sets based on the functional roles like developers versus non-developers. Furthermore, the permission settings are defined for customer PII data or the sensitive financial data. And all these are designed keeping in mind the SOX and GDPR compliance requirements. All the reports and the dashboards in Looker are organized into spaces based on subject areas like sales or marketing or finance. And all the access controls are applied at the space level. So this way, we can do a better content management within Looker. So continuing with the Looker usage, we get more than 8,000 queries per week. And as I spoke about the space-based organization, we have over 300 public spaces in Looker. And in just last 90 days, more than 2,000 reports were executed. So with so much going on in Looker, the question is, how do we keep everything under control? So that's when the data education becomes really important, and especially when we have distributed ownership of Looker. So we have established a Looker help channel on Slack where people can ask questions and get help. So today it has evolved into a self-managed forum with more than 150 people actively contributing. We also host user training sessions as and when there is a new feature or a model or a reports are released. We host regular office hours where you can just walk in and get your questions answered by our core team of analysts. Documentation also comes very handy when dealing with so many users. So we have developed several how-to articles that helps users to navigate within Looker and also find what they are looking for. We keep up-to-date documentation on our models and some of the key reports. Data governance also plays an important role in keeping your reports and dashboards under control because they provide cross-functional alignment and allows us to standardize and create governed metrics. So that way, we can reduce the redundancy of reports and data sets on our platform. So next, let's talk about the performance. So since we have such a big scale, there are two major systems for analytics, which is Looker and Redshift. So let's talk about how do we deal with the performance for these two systems. So for Looker, we would like our Looker to be lightning fast, and we would want all the queries and reports written really fast. Well, it doesn't happen on its own, and you do have to take some actions or take some actions to basically get the desired performance. So here are few things that we do in Looker. So the first is we use persistent derived tables. So the derived tables are essentially the physical copies of the pre-calculated data sets in Redshift. Now, since the results are stored in Redshift, the queries no longer have to calculate the results on the fly, essentially improving the performance. Now, cherry on top is that you can also add indexes to these derived tables. And if you are using Redshift like us, you can add sort keys and define distribution styles for these tables. So next is the model design. So we take specific measures in defining our attributes as dimensions or measures. We also pay close attention to join cardinalities or the table relations because all this information gives Looker a good context to generate optimized queries. The next thing that we use is templated filters. So templated filters are applied on the derived tables, and which allows us to restrict the data sets by certain criteria, essentially generating the subset of the data. Enforced filters, on the other hand, are applied directly to the reports, where one such example is we restrict the reports with very large data sets to be run only at the 7-day window at a time. Looker also provides a default caching mechanism, but you can also customize it to get the desired refresh rate. And last but not the least is explain feature in the SQL runner. Since we have lots of exploration activity happens through the SQL runner, explain feature really gives you hints to fine-tune your one-time SQL queries. So Looker is not the only system where we have to pay attention, but Redshift also plays an important role when it comes to the performance. So here are a few things that we do for Redshift. The very first thing is we run vacuum and analyze operations on nightly basis. So vacuum operation allows us to reclaim any unused space in our cluster. And the analyze operation collects the metadata about most of our large tables and keeps it up to date for the query optimizer. We carefully define distribution style for all our tables to make sure the data is evenly distributed across the cluster. Sort keys are very similar to the indexes in relational databases, and it helps in improving your query performance. Compression encodings are applied at the table column level, which allows you to optimize the space on your cluster. Workload management is a very important feature of Redshift that really helps when it comes to performance. So when user executes a query, it is assigned to a specific queue in Redshift. And there are certain parameters that you can use to customize the performance for a queue. For example, we use concurrency level. So concurrency level is essentially the number of user queries that can be executed against a queue in parallel. The second thing is you can define how much percentage of memory that should be used by a given queue. User groups is also another way to optimize the performance, where you can define, you can create a group of users and then assign that group to a specific queue, so that if the query is executed from one of those users, it always goes to a specific queue. Auto timeouts is another important feature where you can kill any long-running queries on your cluster automatically. Typically, we try to set that at 10 to 15 minutes for most of our Redshift clusters. So all this is fine, but you must be wondering how exactly the business is being benefited with all this hard work. So let's talk about some of the insights that we are able to provide using our platform. So when it comes to insights, it's only useful if you can actually act upon it. So it's all about the action. With our analytics platform, we are able to provide some of the actionable insights, and let's walk through some of those. So the first is the customer segmentation. So our sales and marketing teams segment our customers using various attributes throughout their customer lifecycle. We collect all these attributes on our analytics platform via various processes involved in customers' journey on our platform, like sign up or product usage or product spend, and provide insights that can help them segment our customers. The next is a net new business. We collect a lot of customer spend data on our platform and provide insights into net new business for each product category or new geolocations. We also hold all this revenue data so that our finance teams can do historical trends on our revenue-based data sets. Customer acquisition is probably every marketing team's favorite topic. And we provide insights through how our customers have come to Twilio. Like, did you come from a Google search, or did you came through a Facebook feed? And all these insights help our marketing teams channel their acquisition and campaign efforts. Sales and marketing funnels is an interesting story for us. Initially, our sales and marketing teams were tracking two different funnels based on how customers arrive to Twilio and also how they are engaging with our sales teams. Now, the goal of both of these funnels was to track the conversion rate and velocity. What it means is that basically how many people are moving from one stage to the other, and also how long does it take. Now, one of the challenge was both of these funnels lived in a complete isolation, and there was no visibility across customers moving from the one funnel to the other. So that's where our analytics platform solved the problem by identifying the customers across these funnels and essentially generating a unified funnel that can be used by both the teams. Customer lifetime value is another important metric driven by insights, which helps us determine how much we can afford to acquire or retain our customer. And any analytics system cannot live without its financial metrics, so as ours. We also provide variety of revenue metrics on our platform and provides insights into a financial health of our company. So next, let's just talk about some customer-centric metrics. At Twilio, one of our core values is to wear customers' shoes. Now, we can only do that if we know our customers. So as an analytics team, we provide insights into various customer touch points that can help us better understand our customers. So let's walk through some of these touch points. The first is the sign up. So this is the first time when we become aware of our customer. And we provide insights into their website behavior, like first visited page or last visited page, which can help our teams better understand our customers so that we can gear you towards right products. Once customer starts generating revenue on our platform, we track various spend thresholds. Now, movements across these spend thresholds allows us to understand our customer spending behavior. Similar to the revenue, we track various product interactions as a variety of usage milestones on our platform. Same thing here, that movements across these milestones helps us take proactive actions for our customers. For instance, if there is a sudden increase in a product usage, that might indicate that our customers are launching a new application or they are running a seasonal campaign, and where we can help you scale your application. And on the other hand, if there is a sudden drop in product usage, that might mean that you are facing a product issue or some quality issue where we can help you troubleshoot and fix that. So next is engagement. As earlier I spoke about the Runtime Developer Experience program, it focuses on providing a seamless experience on our platform. From sign up to launch, the insights that we provide that helps Twilio provide proactive support and training for our customers. And last is the churn. I think churn is one area where insights can really help you retain your customers. We track churn using a lot of spend data. We also use that data in conjunction with the support tickets and the usage data to drive further insights into churn. So these are all the customer touch points where we provide insights and that help us understand our customers better. So in the end, I would like to say that analytics is truly a journey. We have traveled miles, but we still have a long way to go, and we are continuously evolving our architecture and our services to fuel the data-driven culture at Twilio. So with that, I'll hand it back to Daniel.
Thank you, guys. I love that presentation. As somebody who's gone through what they have gone through myself, they talk about it as if it's no big deal, but it's really hard to do what they're doing, and particularly at the scale that they're doing it. And I think one of the key things to note is, and one of the great things about the joint presentation is that there are huge technical challenges, and there are also huge person challenges, right? Business challenges and training and documentation and all of those things. And without both of those pieces, there's no way that you can scale an analytics culture the way that they are, because the technology has to be responsive enough that people, when they go to ask a question, they can get an answer in a reasonable amount of time. But you also need to empower people to make sure that they're asking the right questions, that they know where to ask the questions, that people who are deeply knowledgeable about a particular analytics area can contribute that expertise back to the sort of from that spoke back to the core hub, because if they don't do that, you're really missing out, right? The knowledge that a finance person is going to have about the numbers that drive their everyday business experience are very different than the level of expertise that the analytics team is going to have, right? Those finance folks have a gut feel, a tactile feel for what those numbers should look like, and when they're wrong, that an analytics team that's responsible for data across the organization is never going to have. And so involving those folks in the process in a real substantive way makes all the difference in the business value that you're actually deriving from the data that you're collecting. So I just want to hit on a couple more things that you might not know about, and then we'll open it up for any questions, which I'm sure will be for Rahul and Dara. which is fine by me. So one cool thing about AWS is just the sort of openness of the platform and the fact that they let you do everything and will give you data about what is happening. One of the things that can be tricky is actually making sense of that data. I speak from experience. And so, one of the things that we've thought about a lot at Looker, because we're huge users of AWS, is we have access to all this data. How can we actually get more business value from it? And one of the ways that we've done that is by building what are called Looker blocks for this AWS data. And what Looker blocks are is they're pre-built analytic solutions that you can deploy on your Looker instance to get value much more quickly from the data that you're collecting. And because LookML, the modeling language that sort of sits at the heart of Looker, is just code, we can give you that code for free. It's not a black box. You can see exactly what it's doing. And because everybody's needs are slightly different, you can then go in and customize it. So you don't have to start from scratch. You don't have to start from 0. You can start from 90% of the way there, but then you can customize that last 10% to meet your exact needs. So what we've done, the sort of key ones that we've identified as our own internal needs, and so have put out in the Looker blocks directory. One is for Redshift optimization. Dara talked about the explain statements. How many people have ever looked at an explain statement from Redshift? Yes, no? Wow, only a couple of people have had this very terrifying experience. The rest of you are very lucky not to have had to do that. But so Redshift gives you enormous amounts of information about where data lives and which nodes it's being shuttled from and where the fanning out is happening and all of that. But it is not necessarily the easiest to make sense of. So one of our great analysts said, well, I can write some LookML that knows how to make sense of that, right? And so that's what our Redshift optimization block is. We worked with AWS to validate it and make sure everything was right, but what that allows you to do is look at the query level and look at a particular query that's not running as fast as you want, and rather than being presented with dozens of lines of explain statement, you can get a nice dashboard that explains to you exactly what's happening, where the bottleneck may be, what kinds of tactics you might want to use to get better performance out of that query. And so that's available on the Looker blocks directory. Another one is security and monitoring. CloudWatch gives you an enormous amount of data about what's happening with all of the AWS services that you're using. But again, it's pretty raw when you get your hands on it, right? They're CSVs. And so we built a block that takes that data and presents it in a much friendlier format so that you can see exactly what's happening with which parts of your Amazon infrastructure. I'd be remiss to mention on the Redshift one, actually there's query level optimization and also table level optimization, because that actually ends up driving a huge amount of your performance is not the actual query, but how is the table structured, what sort keys are declared, what distribution keys are declared, is there skew, is there sort key skew, which was a new thing I only discovered existed when the Redshift engineers told me a couple of years ago. Never heard of that one. So we give you the tools to actually understand exactly how your tables are structured. If they're structured well, flag tables that maybe are very skewed that you might want to redistribute or declare a new sort key on. So we've got the two Redshift blocks, the security and monitoring by AWS block. And then finally, for those of you who are spending a lot of money on AWS, there might be ways to save yourself money. And so the cost and usage analysis is another block that we provide where you can take that raw data, which comes in, again, very wide CSVs, not exactly the easiest thing to parse, load it into S3 where it goes, or load it into Redshift, and all of a sudden you can see, how much of my usage is reserved instances versus on-demand instances, which services are using the most money, how can we save money. We actually used this and are saving, I don't know, $500,000 a year or something based on the insights that we gleaned internally from this. So if you're a big user of AWS services, this might be a great way to take a look at what you're doing and think about whether or not you could be saving your company some money, which is always a good way to make friends across your company. If you're a technical person, show them how you will save them money, and they will give you more resources to do what you do. So with that, I'm going to open it up to questions. We have a microphone, but I feel like if people have questions, just yell them out and we'll repeat them so anybody who's watching on video can hear them, and then we'll do our best to answer them. Yeah?
What would you recommend as the best strategy to start dipping into it if we don't do a lot and what we do is very separate?
Yeah.
What would be the first step as a small to medium-sized people?
Okay, so the question is, we want to get started. And I should say, before we answer that, for anybody who's interested, if you want to see more about Looker or hear more about Looker, we're here at the ARIA at booth 210, and I believe I will be the only one offering you the opportunity to experience data in virtual reality. If you're over at the Venetian, we have Look VR, which is built on our API, and you can throw on a headset and explore your data in virtual reality, which is crazy cool. As it turns out, I was a skeptic, but it's pretty fun. So the question is, how do I get started? Like, I wanna dip our toes in the water. What should we do? Guys, what do you think? You want to take that? Should I take that? Okay. I mean, I would say part of the real change that's come about by the sort of cloud databases and all of that is you can just get started by just starting, right? You don't have to, there's no huge capital expenditure that predates doing stuff. You can just go spin up a Redshift instance and start playing to see if you can get value. And that Amazon will give you free credits, so you can even do it for free. My experience with Redshift compared to a relational database is that it will blow your hair back. It just is so fast and so powerful, you will be stunned. But yeah, I mean, I think just start doing stuff rather than coming up with a grand master strategy. Just start doing stuff. Focus on bottom line metrics that will drive business value. That's how you get more resources to do the next thing. And don't, as they said, Rome wasn't built in a day. It's a journey. Just start doing, and you'll learn far more than you could learn, through 6 months of intense planning. Cool. Yeah.
How do you guys handle duplication of data in Redshift? Because Redshift doesn't enforce the unique constraints.
Yep.
And especially when you hook it up to something that doesn't really have like exactly one delivery, you might end up with a couple of duplicate.
Yeah, so the question is about Redshift and duplicate data. Redshift, like a lot of columnar databases, doesn't enforce primary key uniqueness. And so that means you can accidentally end up with 2 copies of the same piece of data, particularly if you're hooking it up to something that doesn't enforce once-only delivery. Do you guys want to talk about that in the context of your architecture?
So I think what we have done is that since we are doing a lot of transformations outside of Redshift, we have augmented our processes to do the deduplication and also put in an automated checks to make sure that before we load the data in Redshift, it's basically clean, there are no duplication, and we have established the uniqueness. One other thing is that in Redshift, you can define an identity column that will give you unique ID for each record. But I would highly suggest that do this outside of Redshift before you load the data in Redshift.
What kind of technology would you recommend?
So a lot of our processes are all in-house. So we are using Spark heavily. We have a lot of Python-based processes as well. So it's basically, since it's all custom built, it's all in-house, we have just augmented the functionalities within those.
Yeah, I mean, I'd also add, just from my own experience with Redshift, you can do deduplication in Redshift. It's not ideal, but you can, particularly if you're doing windowed deduplication. So for example, if you're looking at data from the last day, you only need to compare it to data from the last day to make sure that there's no duplicates, right? And so I think a lot of people make the mistake of comparing last day's data to the last year's data, which is unnecessary. So as long as particularly when you're dealing with time series data, which is usually where this comes up, you can absolutely do deduplication in Redshift, and particularly then vacuuming and analyzing, which Twilio does every night, becomes particularly important, because if you do catch those accidental duplicates, what you're going to do is you're going to delete them. And so then you've got some extra space in the middle of your giant column that you're going to want to reclaim and maybe resort. But Redshift also has there's some great stuff in the Redshift docs about doing sort of partitioned tables basically, and then using a materialized view so that none of your individual tables become so huge. You can vacuum each of those, a month's worth of data, a week's worth of data individually, but then when you address them through the view, which knows about all of the tables going back forever. So it looks to your users like it's one giant table, but for maintenance purposes, it makes it a lot smoother.
Mm-hmm.
Yeah. Yep. Uh-huh. Mm-hmm.
And then, so my question is, are you using Kafka as the context of ETL and streaming of data events? That's one question. The second is...
Wait, let's let Rahul answer that. Okay, so the question is, are you using Kafka as part of your sort of ETL pipeline?
So basically, Kafka is used where instead of extracting data from MySQL, we are using Kafka. So we're not putting too much pressure on our MySQL transactional databases. So we asked our engineering teams, okay, why don't you send this data through Kafka so there is Kafka stream processor, right? You can do transformations, map and reduce functions there itself. And then we push it through our Spark streaming pipeline where you can do transformation and then you can create data frames and data sets and do those transformations and directly load it to Redshift.
All right, second question.
Yeah,
S3
it's
is
a
really
data
acting
lake.
as a state- yeah.
We are using it as a data lake.
Yeah, S3's infinite scalability makes it a great data lake, and particularly I would recommend if folks haven't played with Athena or Redshift Spectrum, all of a sudden the data in S3 in your data lake becomes much more accessible because you don't have to, you're not forced to load it into Redshift to start just exploring. If you want to go find some anomalous event, you can do that through Spectrum or through Athena without ever pulling data out of Athena. Or out of S3, excuse me. And so that just makes it easy to find that piece that you want to load into Redshift and do more exploration with.
Yeah.
Cool. Yeah.
How do you store the data on the database side? Like, do you have a STD type 2 or do you store from the dimensions? Do you store like a time series or do you store like STD2 type where you have a history and you can go back and
Yes.
So the question is, how do you store the data in the data warehouse? Is it time series data? Yeah. Go ahead.
Yeah, I think so. For most of our large dimension does have a time series data, and I think one of the reason is that we do the time-based partitions on S3 before it's getting loaded. So part of that is that I think we do have some of the SCD type 2. We are not using that like heavily for most of our dimensions, but there are few dimensions which does have that. And again, here also we prepare that before we load it into the Redshift. So all the attaching all those current record attributes and time-based attributes.
you read the data out of Redshift every time you prepare?
No, we do that before we load it into Redshift. So we perform the transformations within Spark using the S3 files.
Yeah.
So
Yeah, so
exactly.
yeah, the lookup happens through Spark. Since
Spark and
everything is in
S3.
S3, we can directly do it through S3.
Yeah.
Cool. Go ahead. Yeah.
if you were starting over, would you give Athena consideration versus...
Absolutely.
Yeah.
In fact, we are considering to move towards Athena or Presto or something that will support SQL on file system, because right now our architecture has 3 big Redshift clusters, and there is certainly a room to replace one with either Redshift Spectrum or Athena.
Yeah, and I think I'd just say,
My question is related.
yeah, go ahead.
Do you think Athena plus S3 can replace traditional Redshift? What would be the trade-off of this?
Yeah, I mean, so the question is, can Athena and S3 replace Redshift or other data warehouses? And I'd say, I think Athena and Presto and all of those are great for a lot of things. I don't think that the performance or cost, the cost per query model can be a little tricky in terms of containing costs, and with Redshift you know your costs ahead of time. But I think, as I said at the very beginning, the databases only keep getting faster and more powerful, and so we do not have infinitely fast, infinitely cheap databases yet. But when you look at those cost curves and those speed curves, we're getting there. The asymptote is coming. So I think build to what's available now and assume that what's available next year will be even faster, even cheaper, and it's okay. I think part of the embracing the whole ecosystem, as Twilio has done and as Looker is really architected to do, is is knowing that you build for what's the best fit for your needs today, but also know that you are going to be swapping components out later and replacing them as better things become available, and that's okay. Good, yeah.
Can you talk about your Airflow experience? Has it been working fairly well to restart jobs, make them more resilient? One of the things in your phase 2 was job management and failures.
Yeah.
How did it help resolve some of that?
Yeah, so questions about Airflow,
Yeah.
what the experience has been.
I would certainly say that it was really helpful because we had like 4 to 5 different services, and like I mentioned, we were using cron scripts to schedule our jobs, and like all ETL processes, we run everything at night, right? And if something fails, or if something doesn't run or takes more time, all your jobs run, and then what happens is you result in incomplete data sets, and you just rerun all the jobs. It used to take a lot of time. With Airflow, you have a single unified view where you can schedule all your jobs, you can write everything in DAGs, and then you can define dependencies. There are a lot of other options as well, like you can spin up more workers, and then you can retry emails on failure. So there are a lot of functionalities that come with Airflow itself that you'll find very useful, like we found it. And then it also helps you to visualize everything, right? If you see anything, if it has a visual view, you can easily click on a job and run it. So it was very helpful for our architecture. It helped us tremendously.
So we're being given the wrap-up signal. Thank you, everybody. If folks have more questions, we'll hang out, and you're welcome to ask them. But thanks, everybody.
Yeah.
Thank you.